Now we're going to talk about the manometer. The manometer actually measures and indicates pressure using area and weight of a column of liquid. As you can see from the figure we have here, you can see we have a pipe and you can see the flow of water, and then you can see we have a manometer connected to the pipe. Okay, so what you will see here at point M and point N, these are equipotential points, so the pressure at these 2 points will be the same, so they are going to cancel out. Pressure at point M and N will cancel out eventually. We have said that our notation of flow is such that whenever there is a flow downward, you use a positive sign, and whenever there is a flow upward, you use a negative sign. And since this height and this height are the same, the potentials of pressure are the same at these 2 points, plus and negative will definitely cancel out because they are going to have the same values at the end of the day. Okay, and also you will see that because fluid is flowing downward, we add positive sign here. All right, and then it is also flowing, oil is flowing downward here, we use positive sign. And as you can see, mercury is flowing up here, it's flowing upward here, so that's why this is going to be a negative sign. Okay, so there are different types of heights for different levels and flow of fluid or liquid in this particular pipe and the manometer. Okay, you can see we have a 7.22 feet for oil up to this particular point in the manometer, and then you can also see we have 1 feet height for mercury in the manometer somewhere right up here, and so on and so forth. Okay, so a vertical pipe containing oil with specific gravity of 0.91 is shown above. If the specific weight of water is 62.4 pounds per cubic feet, then specific gravity is given as 13.6. Specific gravity does not have unit because it is usually given as the specific weight of a liquid or a material divided by the specific weight of water. So the units are going to cancel out. The question then says, what is going to be the pressure at this particular point A? How do we find the pressure of oil at this particular point A in the pipe? Okay, we know that PM will be equal to Pn, so pressure at point M will be equal to pressure at point N. All right, that's what we have here. So we can easily say that since pressure at point M will be, this is point M, the pressure at point M will be the pressure of oil in this pipe plus pressure of oil in the manometer. Okay, so you can see we have pressure at A, which is the pressure of the oil in this particular pipe, plus the pressure of oil in the manometer. The pressure of oil in the manometer will be equal to the specific weight of oil multiplied by the height of oil in this manometer, and that's exactly what we have here. So this is pressure at point A plus pressure of oil in the manometer equal to pressure at point N, which would be equal to specific weight of mercury multiplied by the height of mercury. Okay, so if we take it further from here, we do know that we are looking for PA, so we leave the PA the way it is. The height of oil, we already have the height of oil 7.22, so we can easily replace H oil with that. Then the specific weight of oil can be given as specific gravity of oil multiplied by the specific weight of water. So you will replace this specific weight of oil with specific gravity of oil multiplied by specific weight of water. That's exactly what we do have here, equal to the height of mercury multiplied by the specific weight of mercury, which can also be replaced with specific gravity of mercury multiplied by the specific weight of water. So we have PA plus H of oil was given in the question as 7.22. Specific gravity of oil is given in the question as 0.91. You put that here. Specific weight of water was also given as 62.4. And for height of mercury was given as 1 feet in the question. Specific gravity and specific weight of water were also given already. So if you put all of those here, you can easily rearrange, multiply out, rearrange, and then find your PA to be equal to 438.6 pound per square feet. So if you are wondering how we got PA plus pressure of oil in the manometer, the pressure at M will be pressure at this particular in the pipe at this particular point plus the pressure in this oil. That will give us the pressure at this particular point here. Okay, and then the pressure at this point will give us the pressure of mercury. All right. So this is one way of solving the problem. There is another way you can solve the problem by using the sign notations that we talked about. If you want to use the second method to solve that problem, you can use that. Here they use the sign notation. If you look at the particular diagram given to us, you will find out that the pressure PA, the fluid or oil in the pipe, is flowing downward. So that is why you're going to have a positive sign here. We had said that when the fluid is flowing downward, you use a positive sign notation. When it is flowing upward, you use a negative sign notation. So PA, the fluid or oil, is flowing downward, so you have plus PA. Also, the oil in the manometer is flowing downward, so you're going to be plus pressure of oil in the manometer. And you know, pressure of oil in the manometer is equal to height multiplied by specific weight of oil. So that is why you have the plus here. Then for the mercury, you will find out that the mercury is flowing upward if you go and look at the question properly. As you can see here, the mercury is flowing upward here. So it's going to be a negative sign. That's exactly why you have minus H mercury, height of mercury, multiplied by specific weight of mercury. You add everything together and you equate it to 0. Okay, when you do that and then you rearrange and multiply all those values out, after substituting the respective values in the equation, you would obtain the same thing, which is pressure at A equal to 438.6 pound per square feet. So you can either use this method or you can use this method to find your PA. Here is another question we can easily look at. In this particular question, you will see that we have a reservoir that contains 3 types of materials. We have the air, we have the oil, and then we have water. And we assume that they are immiscible liquids, so they will not mix. Right from the bottom of the tank, we have 0 to the top of the tank, which is 6 meters. It means that the height for here is going to be 6 minus 5, and that gives us 1. And the pressure of air is given as 30 kilopascal, as you can see. Okay. If you scroll down, you will find that for oil, the height of oil will be 5 minus 2, and that is just 3 meters. And then the pressure of oil is not given, but the specific gravity of oil is given. You take note of that. Also, for the compartment where we have the water, the height is going to be 2 minus 0, that's 2 meters. And we know the specific weight of water is a constant. And then here is the height too. Okay, so we'll keep all of those. If you then come here, you will find out that inside this manometer, this is a manometer connected to the reservoir or the tank. You will see that the height of water in the manometer is 1 meter as given here. Okay, and as you can see, water will be flowing down. If water is flowing down, it simply means that the pressure of water in the manometer is going to be positive. Again, we have mercury right at the bottom. Because they are immiscible liquids, they will not mix. So they will be separated in their various compartments. So if you have mercury right at the bottom here and it is flowing up, the height of mercury as it flows up is given as Y. So because mercury is flowing up, we're going to represent that flow with a negative sign notation. Alright? So when we are calculating, we'll pay attention to that. The question then goes ahead to tell us to find Y. The question then says we should find Y. Let's begin. You add all of the pressures together, and then you equate it to 0. You add all the pressures in the tank and the pressure in the manometer together, taking cognizance of their sign notations, and you equate it to 0. So let's begin. The pressure of air is 30 kilopascal. It's given, that is plus. Pressure of oil is also going to be plus because it's flowing down. So you have pressure of oil plus the pressure of water is also flowing down. You put that here plus the pressure of water in the tank, then plus pressure of water in the manometer. Okay, this is going to be pressure of water in the tank, then this is going to be pressure of water in the manometer. You put that there, and then minus pressure of mercury in the manometer. Okay, the pressure of mercury in the manometer is usually going to be given as the height of mercury multiplied by the specific weight of mercury, and that is why we have minus y multiplied by specific weight of mercury, and then you equate everything to 0. Once you have this written out, 50% of the problem is solved. All you need to do is go ahead and substitute the values right in. We have 30 plus the pressure of oil, will just be specific weight of oil multiplied by the height of oil. So the height of oil is 5 minus 2, as you can see. For oil it is 5 minus 2. So that becomes 5 minus 2 multiplied by specific weight of oil plus 2 minus 0 multiplied by specific weight of water that we do have here, plus 1 times specific weight of water will still give us specific weight of water here, equal to, if you take these entire expression to the other side, it will be equal to y multiplied by specific weight of mercury. So we don't know the specific weight of oil, but we do know the specific gravity of oil. Specific weight of water is 9.79. This is a constant. Specific gravity of oil was given as 0.82. So if you put that here, this becomes 5 minus 2, that is 3, multiplied by specific gravity of oil, which is 0.82, multiplied by specific weight of water. This specific gravity of oil and specific weight of water is equivalent to the specific weight of oil. So specific weight of oil is what we have here, plus 2 minus 0 is 2. Specific weight of water is 9.79, you put that here, plus specific weight of water, which is 9.79 again, equal to y multiplied by specific weight of mercury. Now, specific weight of mercury can also be written as specific gravity of mercury multiplied by specific weight of water. We do know specific gravity of mercury to be 13.6. Specific weight of water is 9.79. You put all of those here and then you multiply out. When you do that, you will find out that your y is equal to 0.6267 meters. In a different manometer, you will have minimum 2 different liquids that are immiscible. Minimum of 2 different liquids that are immiscible. Okay? What you can see here is a manometer. Okay? And you can see we have a pipe A and a pipe B right here. And there is liquid flowing from pipe A right into the manometer. And then you can see we have a liquid C here. And then you can see we have a liquid B here, okay? So there are 3 different types of liquid we do have here. For pipe B, we have liquid B. For pipe A, we have liquid A. And then there is another liquid C right in the manometer. So you should be able to understand how this works. For example, in the pipe A, if fluid is flowing upward here, if liquid is flowing upward here, you're going to represent with a negative sign. Okay? The liquid flowing downward will be represented with a positive sign, and then the liquid flowing upward, a negative sign. Another liquid flowing downward, a positive sign. Okay? So pay attention to all of these. Here is a simple question we can easily use to demystify our explanations. You can see we have a pipe A, and then from this pipe here, right to this particular level, we have a height of 66.6 inches. And then we have water right in this manometer. This water is flowing downwards. Okay, so you know this is going to be positive, and it has a height of 66.6 inches. So for water, the height is given. Also, this is another liquid, and this is going to be mercury. The mercury has 40.3 inches height flowing up, as you can see. So we have 40.3 inches of height flowing up. So this is going to be a negative sign. This is going to carry a negative sign. Okay, and then we keep going, and right here we have water. The water height of water given here is 22.2, and this is going to be flowing down. If this is flowing down, that simply means it will be negative. Okay, so it will be 22. It will be minus 22.2 inches. We are going to represent this with a negative notation. Also, right in this manometer, we have another liquid, and it is going up. Okay, mercury is flowing up. if it is flowing up, it's going to be negative. So you're going to use negative sign to represent these. Negative sign, and we have 30 inches for that particular height. Also, we have another type of liquid here. This is also flowing upward. Okay, as it is flowing upward, this is going to be negative sign too. So it's going to be minus 10 multiplied by whatever it is you need to multiply it with, and then you are going to equate it to B. Okay, so everything coming from this particular side, all the pressure from A, you're going to add all the pressures here together and equate it to the pressure in B, starting from A. And you must take into consideration the sign notations. So the question then says, find the pressure difference between pipes A and B. Don't forget, pressure A plus pressure of this water plus pressure of this mercury plus pressure of this water plus pressure of this mercury plus pressure of this particular material must be equal to pressure of B. Okay? Pay attention to that. Let's begin. We have been given the specific weight of water to be 62.4 pound per cubic feet, specific gravity of mercury. So this liquid here, after all, like I mentioned, is this liquid, like I mentioned earlier, is mercury. So we have specific gravity of mercury to be 13.6. What you want to do is, you will notice that the specific weight of water given is given in pound per cubic feet, and we have our height in inches. You can't combine inches and pound per cubic feet together, so you have to combine this height to feet. To combine height to feet, you are going to divide by 12. You're going to divide all the inches value by 12 to convert the height in inches to feet. Like I mentioned earlier, we know the specific gravity of mercury to be 13.6, and we know the specific weight of water to be 62.4. And specific weight of mercury will be equal to specific weight of water multiplied by specific gravity of mercury. We mentioned that earlier. That's like a general equation we've been working with right from when we began this topic. Hence, you can easily find the specific weight of mercury by multiplying these out, and then you find 848.64 pound per cubic feet. You keep this somewhere. So let's add all the pressures together. Pressure of A, like I mentioned, plus the pressure of water will be equal to the height of water multiplied by specific weight of water. If you look at the diagram again, that's what we're going to have here. This is it here. Height of water multiplied by specific weight of water will give us the pressure of this water. It is flowing down, so the sign is going to be positive. So you see we have plus 66.6 divided by 12 multiplied by specific weight of water. We are dividing by 12 because we are converting the 66.6 inches to feet. Okay, so let's go ahead. For this mercury, the pressure of mercury at this particular point will be equal to, the pressure here will be equal to the height of mercury multiplied by the specific weight of mercury. The mercury is flowing upward, we're going to have a negative sign. And that is why when you look at what we do have here, you see that we have minus 40.3 divided by 12, converting inches to feet, multiplied by specific weight of mercury. Also, plus water. Water is flowing down, so you're going to have plus 22.2 divided by 12 multiplied by specific weight of water. This particular mercury is flowing upward. If you look at the diagram again, you will find out that specific mercury is flowing upward. So you have minus 30 over 12 multiplied by specific weight of mercury. Then the last version, the last point, this last point is 10 inches and it is water flowing upward. So we do have, since water is flowing upward, it will be minus 10 over 12 multiplied by specific weight of water. You then equate everything to pressure at point B. Please take note of this. All the pressures starting from point A, you add everything together and equate them to the pressure at this particular point. This is very important. Okay? So if we carry out necessary substitutions, we know the values of all of these. We know specific weight of water. We know the specific weight of mercury, which we calculated right up here. And we also know the specific weight of water, which has been given. We put that here and we carry out some calculations, and this is what you find. You end up with PA minus 4561.816 equal to PB. Since we are looking for pressure difference, it means we are looking for PA minus PB. You bring PB to the other side, take this to the other side, and you're left with 4,561.9 pounds per square feet. That would be the pressure difference between point A and point B. Here is another simple question we want to look at. We can look at together, okay? And this is a very important one. You can see we have pressure of water right here. And what we are looking for is pressure at point A minus pressure at point B. So it means we are also looking for pressure difference. Alright? You can see we have height of water here. Since we are going up, we're going to have a negative pressure for X. We're going to have a negative pressure for oil. This time around, the liquid here is oil. We're going to have a positive pressure for water because this is also water and it is flowing down. It will be positive pressure. And then we equate everything to the pressure at point B. Okay, so let's get started. We have been given the specific weight of water. This time around, specific weight of water is given as 9.79 kilonewtons per cubic meter. And of course, we have the specific gravity of oil as 0.8. So, looking at our question, what you will find is that we have plus PA minus pressure of water here based on this height. Pressure of water based on this height will be equal to specific weight of water multiplied by the height of water. Okay, height of water is X, specific weight of water, we know it. So this will be minus X times specific weight of water. That will be the pressure due to this height. And that's why we have minus X multiplied by specific weight of water here. Okay. Also, if you look at this diagram, you will find that we have oil and we are going up. The pressure is upward. Hence, this becomes negative. The pressure is going to be negative here too, since it is upward. So it becomes minus 0.7 multiplied by specific weight of oil. And that's why you have minus 0.7 times specific weight of oil here. Again, for this water, you will see that the height here is X minus 0.8. But in this case, water is flowing downwards. So the pressure is going to be downward. Hence, it will be positive. So we have plus pressure of water at this point due to the height X minus 0.8. And that pressure will be equal to X minus 0.8, the height, multiplied by the specific weight of water. And since we are flowing down, it is going to be with a positive notation. So you can see here we have plus X minus 0.8 multiplied by specific weight of water. And everything will be equal to pressure at point B. Alright. All we need to do is substitute what we do know. If you first of all expand the bracket, let's expand this bracket since we don't even know X yet. Let's try to expand this bracket and see what is going on. This becomes minus X specific weight of water. You keep this. Okay, you keep this. If you expand this, this becomes X times specific weight of water. You have this minus 0.8 times specific weight of water. You keep this equal to PB. Specific weight of water, because this has a negative sign and this has a positive sign, they will cancel out. And you're going to be left with 0.7 multiplied by specific weight of oil. And specific weight of oil will be equal to specific gravity of oil multiplied by specific weight of water. And that's what we have here. This is specific gravity of oil. This is specific weight of water. And that represents specific weight of oil. Multiplied by 0.7, you have is 3 here. Then minus 0.8 multiplied by specific weight of water, you put that in here, you equate everything to PB. Alright, you will notice that the X terms have disappeared. Hence, you can easily find our pressure difference, which is PA minus PB. PA minus PB would be equal to, after we have multiplied everything here out, we'll take them to the other side, and that will give us 13.31 kilopascal. Again, I would like to encourage you to pay attention to the sign notations. When pressure is upward, you use a negative sign notation. When pressure is downward, you use a positive sign notation. What happens in the cases where we have inclined manometers? When the manometers are not just on 180 degrees or 90 degrees. What happens when we have an inclined manometer? Okay, let's try to deal with cases like this. Here is an inclined manometer. As you can see, we have a pipe A at this point containing water, flowing into a manometer right in here, and then it keeps going upward, and then it gets to this particular point, and then you can see the pipe is inclined for some reason at this particular top here. Okay, so, and then we have another pipe here, pipe B, that contains air. Okay, and then the diameter or the length of that pipe is also given here as D5. All right. So how do we deal with situations like this? When you have a question like this and you are asked to find pressure difference PA minus PB, this is what you do. We've been given D1 to be 0.3 meters, D2 is given as 0.15, D3 is given as 0.46 meters, D4 is given as 0.2 meters, this is D4, and D5, we do not know what D5 is. Okay? We've been given a specific weight of water to be 9.79 kilonewtons per cubic meters. Specific gravity of water has been given as 13.6. That's a constant, we know that. And then the specific weight of air is given as 11.8 newtons per cubic meters. Okay? Again, what we're going to just do simply would be to add all the pressures starting from A. So you have P pressure at point A plus pressure of water due to this height plus pressure of mercury due to this height D2 plus pressure of mercury due to this height D3. Because we are flowing downwards, pressure of water at this level will be positive because the pressure is downwards. Pressure of mercury at this level would also be positive because it is downward. Pressure due to this height D3 would be negative because this time around it is upward. The pressure due to D4 would also be negative because it is upward, and then we put everything to pressure at point B. Okay, don't worry. Also note that pressure at point B would also be negative because it is also inclined upward. Okay, so pressure due to D5 would also be negative because it is inclined upward. So let's do this. So we have PA plus pressure due to water will be D1 multiplied by specific weight of water plus D2 multiplied by specific weight of mercury. That's exactly what we have here. PA plus D1 multiplied by specific weight of water plus D2 multiplied by specific weight of mercury. The pressure of mercury due to height D3 is upward, so it's going to be negative. That's why we have minus D3 multiplied by specific weight of mercury. And then this is the inclined part, which I need to quickly and briefly explain to you. Here, what you would need to do here is to draw a simple line here. What you can do is to draw a simple line here. Okay, so to form a right angle triangle, and this is going to act like our hypotenuse. We have our angle here, and this angle is going to be 45 degrees, by the way, because it's a right angle triangle. Okay, and we know the hypotenuse is going to be D4. This height is the height that we actually need to use for our calculation of pressure. This height is the height we need to use for our calculation of pressure. Okay, but we don't know it. But since we know D4 and we know this angle, we can find this height. Hence, we can say that this height, so if you call this height y, that means that y would be equal to, if you use sine theta, let's call this place theta, okay? So sine theta will be equal to opposite over hypotenuse. The opposite here, this is sine theta, we know is equal to opposite, which is going to be our y in this case, call it y, divided by hypotenuse, which is D4. Okay, so our y that we are supposed to use to calculate pressure would be equal to D4 sine theta. Our theta is going to be 45 because this is a right angle triangle and all the angles here must be equal to 180. So if this is 90, this is 45, this also must be 45. So that means since our D4, we know our D4 is given, we just do that. D4 multiplied by sine of 45 will be the height that we're going to use to calculate pressure here. Okay, so the pressure here would be equal, since it is inclined upward, it will be equal to minus D4 sine 45 multiplied by specific weight of mercury. The same thing is going to happen to the air because it is also inclined upward. So that's going to be minus d phi sine 45 multiplied by specific weight of air, and everything will be equal to PB. So you equate it to PB, and then you can substitute all the values. Don't forget, you have to first of all find the specific weight of mercury, which is going to be specific gravity of mercury multiplied by specific weight of water to obtain 133.144 kilonewtons per cubic meters. So you see, if you multiply everything out and you substitute all the values we do have right in here, you will find out that we have PA minus PB equal to 57.168 kilonewtons per square meters. This is very important. The specific weight of air is negligible. It is very small, so you may not use it for your calculations, but if you like, you may choose to use it for your calculations. At the end of the day, you will still arrive at exactly or approximately the same value here. Okay? Here is another example where we expect to find the difference between pressure between point 1 and point 2. As you can see, we have a manometer here, and we have point 1 in the pipe that has water flowing, and we have point 1 and point 2. The question says find the pressure drop between P1 and P2 right here. And you can see direction of water flow downward. The distance between point 1 and point 2 is 5 feet, as you can see. And the specific weight of water is given as 62.4 pounds per cubic feet. What you can do from here is to try to draw a simple triangle from here. So just point 2, and you can try to connect those like this. That's a triangle. The angle here is going to be 45 degrees. And you do know that this height is going to be K as given right here. And then this length, hypotenuse, is 5 feet as already given here. It's going to be 5 feet. So from there, you can say that sine 45 is equal to opposite over hypotenuse. That is going to be opposite K over 5. And from there, you can find our K to be equal to 5 sine 45. So this can give you a specific value. So we get the value of our K from here. And since water flowing through the manometer downward is going to give us a positive pressure, so this is going to be positive. This is going to have positive notation when carrying out our analysis. Also, there will be positive notation here. Also, there will be positive notation here because water will be trickling and flowing downwards. When we get to this particular point, the liquid in this particular manometer here, which is our mercury, is flowing upward. So at this particular point, it will be negative. Okay? And then at this point, it will also be negative. But this time around, what we have here is water. So what will be flowing upward here is going to be water, and it will be negative. It will have negative pressure. Hence, it will be negative when we are carrying out our calculations. And you can see the height here is x inches. So if this height is x inches, don't forget we convert all inches to feet. If we want to use this particular specific weight of water, pound per cubic feet, right up here. Okay, so we have x inches here. So all these heights are also in inches. You have to convert all the height we have here to feet. So don't forget, when we start our calculations, it will be pressure at point 1 plus pressure due to height of K plus pressure due to height of water plus pressure due to this particular height minus pressure due to this particular height minus pressure due to this particular height equal to pressure at point 2. That's what we're going to do. So let's begin. This is going to be pressure at point 1, that is P1, plus pressure due to height K, which is going to be specific weight of water multiplied by K, and that's exactly what we do have here, plus pressure due to water here. This height is going to be equal to this height that we have right here, and that is x inches. The height we have here is x inches. So that is going to be the same height that we have here. So it's going to be x inches here. Okay, so it's going to be plus pressure of water due to this height x inches. So you have x over 12 multiplied by the specific weight of water, and that's exactly what we have here. That's going to be pressure due to this height here. And then this pressure, it's not written here, but the height here is actually 6. We have 6 inches here. The height here is 6 inches. Okay, so the pressure due to this particular 6 inches will be equal to 6 over 12 multiplied by specific weight of water. And that's exactly what we do have here. At this particular point, you will see that mercury is going upward, so the pressure is going to be upward, so it will be negative. So it will be minus 6 over 12 multiplied by the specific weight of mercury, and that's exactly what you also have here. At this particular point, it will also be minus x inches divided by 12 multiplied by the specific weight of water, and that's exactly what we do have here. And everything will be equal to the pressure of 2. By the way, this x over 12 multiplied by specific weight of water and this x over 12 multiplied by specific weight of water will cancel out. So when they cancel out, what we are left with P1 plus, what is our K? Sine K is 5 sine 45. You put that right in here. Specific weight of water is 62.4. You put that here. 6 over 12 is 0.5. You leave that here as 0.5. Specific weight of water is 62.4 minus is 0.5 multiplied by specific weight of mercury. And specific weight of mercury would be equal to the specific gravity of mercury, which is 13.6, multiplied by specific weight of water. Okay, that's what we do have here, and then you equate everything to P2. What is left now is to mathematically analyze what we do have here. If you do that, you are left with P1 plus all of these equal to P2. Since we are looking for P1 minus P2, you can take P2 to this other side. So you have P1 minus P2. And when you add all of these and multiply all of these out, what you do have is 172 pounds per square feet. This gives us our pressure difference between point 1 and point 2. Pay attention to the inclined surface calculations that we did. They are very important because you need to know them and be able to use them effectively. Here is another simple question that we need to quickly look at together. What are we looking for? We do have specific weight of water for these manometer as 62.4 pounds per cubic feet. Specific gravity of mercury, as you can see, we have mercury here in the manometer as 13.6. You can see we also have oil here as the fluid flowing in this particular pipe, and the specific gravity of oil is 0.91. That is also given. Again, what you see is that we have a pipe at the bottom, and on this pipe we have the manometer connected to the pipe. So we have 2 points on the pipe. We have point A and point B, and we have the oil is flowing in this particular direction. Okay, so oil is flowing in this direction. All right. So what we are looking for is the pressure difference. Is the pressure difference, and it has been stated that pressure at point B is less than pressure at point A. Okay, and this looks more like a differential manometer. So a differential manometer is attached to the pipe as shown above. Calculate the pressure difference between points A and B. Pressure at point B is less than pressure at point A, just like we have been calculating right from when we started our explanations and calculations. So we are looking for PA minus PB. Alright, don't forget, once oil flows up, the pressure upward due to height X will be negative. Also, the pressure upward due to this height will be negative. The pressure upward due to this height will be negative. And since this height here will be equal to Since the height here is equal to the height here, and this is negative, this is positive, the liquid right in these particular pipe are the same. So this will cancel out. We don't have to include it in our calculation. Also, the liquid here and the liquid here are the same, and the heights are also the same. The specific weight will be the same. The calculations of pressure will be the same. One will be negative, the other will be positive. The one going up is negative, the one coming down is positive. Also, these will cancel out. So we will not need to include this in our calculations because they will cancel out. So when we are going up from here, the only calculation we're going to use or pay attention to would be the pressure due to height x. And pressure due to height x will be equal to the height x itself multiplied by the specific weight of oil. And we have not been given the specific weight of oil, but we can easily calculate that. Specific weight of oil will be equal to the specific gravity of oil multiplied by specific weight of water. And we have those two values here. Okay? So pay attention to this. Also, as we go on, right, we come down here, there is another height here, which is going to be positive, and there's another height here, which is negative. So the height here and the height here, the pressure at these 2 points would cancel out. This is positive, this is negative. This is coming down, this is going up. So they will cancel out. We will not need to use them in our calculations. Okay? So these are gone. So we ignore them. But we do have 4 inches here. We're going to use these. This is upward. So it will be this 4 inches divided by 12 if we're going to convert these 4 inches to feet, multiplied by the specific weight here. Okay? So with that, we can then still go ahead. You will notice that we have another height right up here, and then we do have another height right up here. This is plus, this is negative, and this is positive. This height here is y. Okay, so we're going to pay attention to that. This is positive. We know the height of water here is 4 inches because this height and this height are going to be the same. So this is going to be 4 inches too. This height and this height here is x, as you have seen. Okay, so since this is oil going up and then this is oil coming down, what you will find out is that this height x and this height x are the same. Direction of flow of oil here is upward, is negative. Direction of flow of oil downward here is positive because pressure is downward. So automatically these and these, they would cancel out. Okay, so let's look at the calculations and see how this play out. Eventually what we're going to have left is pressure of A plus pressure due to height x, but since this is upward, it's going to be minus, so it becomes minus x times specific weight of oil minus, this is cancelling out, this is cancelling out, we don't need it, this is cancelling out, we don't need it. The only thing we need now is going to be just this plus 4. So it becomes plus 4 over 12 times specific weight of mercury. This is what we're going to have. Now, since it is going upward, it's going to be negative. Since it's going upward, it's going to be negative. So we have minus 4 over 12 times specific weight of mercury. If I were you, I would not bother to write minus 4 over 12 specific weight of oil plus 4 over 12 specific weight of oil because they would eventually cancel out. Just like I explained to you here, these and these will cancel out. But if you still want to write it, you're free to go ahead and write it. Okay, since this is 4 inches, it becomes minus 4 over 12 times specific weight of oil. That's what you have here. Plus this one flowing down plus 4 over 12 times specific weight of oil. That's what you have here. But they will cancel out. So naturally, I wouldn't encourage you to bother to write them out. But if you don't want to make mistakes and you're not sure what will cancel out, you can decide to write them out. Okay, so you have these minus 4 over 12 times specific weight of mercury plus 4 over 12 times specific weight of oil. At this particular point, this is mercury, this is oil. So oil is flowing down. It becomes plus 4 over 12 times specific weight of oil, and finally plus x specific weight of oil. Also, if I were you, I won't bother to write minus x specific weight of oil because I mentioned earlier that it will be the same and something will cancel out, plus x specific weight of oil. These two will cancel out, as you can see. these two will cancel out, as you can see. So if I were you, at the beginning and at the end, I want to have to write them. These two would also cancel out, as you can see. Okay, so what we will left will be, and then you equate it to PD. What we will left with will be PA minus 4 over 12 specific weight of multiplied by specific weight of mercury plus 4 over 12 multiplied by specific weight of oil equal to PV. At the end of the day, PA minus PV would be equal to 1 over 3 multiplied by specific weight of mercury minus 1 over 3 multiplied by specific weight of oil. You can choose to find specific weight of oil and find specific weight of mercury using the specific gravity of oil and mercury and specific weight of water as given. Specific weight of mercury will be equal to specific gravity of mercury multiplied by specific weight of water. Specific weight of oil will be equal to specific gravity of oil multiplied by specific weight of water. Okay, so you can do that, and once you do that, what you would find out at the end of the day, once you do that, what you will find out at the end of the day is that PA minus PV would be equal to 263.95 pounds per square feet. Everything here is mathematics, so you can use any method of mathematics that you know to solve these, and then you will find out that we have 263.95 pounds per square feet. Okay. Right from when we started, you will notice that pressure B is always less than pressure A, and pressure 2 is always lesser than pressure 1. So pay attention to that too. So this is where this lesson is going to stop. I want to encourage you to watch this video again and again. Make sure you are up to speed about all the calculations regarding manometer and other devices that we have discussed. See you in the next lesson. Bye.